All right, guys, welcome back. Today's warm-up is a two-question warm-up. So here we go. The first one says, if we have 14.9 liters of gas held at a pressure of 5.7 atmospheres and a temperature of 86 degrees Celsius, what will be the volume of the gas if I decrease the pressure to 0.75 atm and decrease the temperature to 11.5 degrees Celsius? All right, so we're given a series of things here. All right, so let's look at our information. We're given liters of a gas, pressure of that gas, and temperature. All right, additionally, that's the beginning temperature. It says, what will the volume of the gas be if I decrease the pressure? So I have a second pressure here. I have a second temperature, and I want to know the volume. All right, so it appears here right off the bat that I'm going to have to use the combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2. So let's go ahead and see what we got here. So pressure 1. So initially I have a pressure of 5.7 atmospheres. I have an initial volume of 14.9 liters. And I have an initial temperature, or a T1, of 86 degrees Celsius, which is equal to 359 Kelvin, because of course I will never work out these problems in degrees Celsius. That's not how it works. All right, then I have a P2 value of 0.75 atmospheres. I have a V2 value that is unknown. That's what I'm solving for. And I have a T2 of 11.5 degrees Celsius, which is equal to 284.5 Kelvin. All right, so all I have to do at this point is essentially just put it into my equation and solve. So P1, 5.7 times V1, 14.9, all over T1, 359, is equal to my P2, 0.75, times V2, which I do not know, and all over T2, 284.5. All right, so when I cross multiply and divide, I should get 67.305. 2507 is equal to 0.75 V2. Solve both sides by dividing by 0.75, and I should get a V2 of 9.0 times 10 to the first, and my volume will be in liters because that's what I started with. All right, so that is the answer to number 1. All right, for number 2 says, if a gas at 98.7 degrees Celsius is at 795 millimeters of mercury of pressure, what will the pressure be in atmospheres if I decrease the temperature to 25 degrees Celsius? All right, so here it appears I'm going to be using Guy-Lussac's law, which is P1 over T1 is equal to P2 over T2. All right, so let's see what we have here. We have a gas at 98.7 degrees Celsius. We have a pressure of 795 millimeters of mercury. I want to know the pressure. All right, so I want to know the pressure, and I have a new temperature of 25 degrees Celsius. So let's just go ahead and write these values down. So I have a P1 value of 795 millimeters of mercury. I have a I don't have a V1 value. I have a T1 value of 98.7 degrees Celsius, which is equal to 371.7 Kelvin. I don't have a P2, but I do have a T2 of 25 degrees Celsius, which is equal to 298 Kelvin. Okay, again, I'm always going to convert to Kelvin because I cannot work these equations by using Celsius. All right, so I'm just going to set this up. 795 over 371.7 is equal to my P2, which is just X, over 298. As I do this, I get a cross multiply and divide. I should get a value of 637.3688458 millimeters of mercury. Now the question is asking for my answer to be in atmospheres. So I'm going to go ahead and do that. There's 760 millimeters of mercury in 1 ATM. So my final answer should be 0.84 ATM. Alright guys, that was our warm-up for today. I hope you guys have a great day. If you have any questions, again, feel free to email me at any time on Canvas. So you guys have a great day. And as always, make good choices.